My name is Roger Koch Barr. I'm here for the bioelectricity course to talk today about a mysterious but also useful group of constants, RT over F, and a couple of other physical constants whose values we need from time to time. Now again, I'd say this is a boring topic, but this is a boring topic that can get in your mind, and if it does, it can be a real mystery. RT over F is used as a kind of a conversion factor between ionic concentrations and voltages. We're not working on the conversion right this moment. It'll come up in a later week, but you'll see this factor, RT over F. And you'll say, what is this R and T and F? So R is the gas constant from chemistry. You remember the equation PV equals nRT from chemistry, the gas law. And R is the constant in that law, about 8.3 joules per mole per degree Kelvin. T in this equation, RT over F, is the absolute temperature. And F is called Faraday's constant. It's the amount of coulombs of charge that's present in 1 mole of material. If you would look these values up in standard references, Wikipedia, and other more technical references, you find they give the values more precisely. But beyond that, there's a discussion of how the values are obtained. It's worth doing it. Please do so. Now, the absolutely amazing thing is that for whatever reason, RT over F is about 26 millivolts. So 26 millivolts is a kind of a constant of nature, something like the value of the charge on the electron. And you ask yourself, why on earth is RT over F 26 millivolts rather than some other voltage? But it is. And when you look into equations and you see RT over F, in your mind you can say, that's about 26 millivolts. And it might vary a little bit, because T varies depending on temperature. It could be a little higher or a little lower. So 26 is sort of plus or minus 10% or so. But it's about 26 millivolts. It's just amazing. Of RT over F, oftentimes people are least familiar with Faraday's constant and think of it as some mysterious number. Faraday's constant is, in a way, the most ordinary of all the values. You just get it by counting or doing a simple operation on two different numbers. First, you take Avogadro's number, the number of molecules in a mole, and that's 6.02 times 10 to the 23rd. I've shown it here. Then you take the charge that's on one electron. You might say, why do all electrons have the same charge? I don't know why they all have the same charge, but it seems that they all do. And that charge is 1.6 times 10 to the minus 19 coulombs. And so the way you get F is you just multiply those two numbers. And so you get the total amount of charge that's present when you have 1 mole's worth of charges. The number of charge that's present in coulombs, the unit coulombs, in a mole's worth of material. So it's quite a bit, 96,487 coulombs. That's a lot. And Faraday's constant is that number. That's all there is to this segment. It went pretty fast, but I made it a separate segment because I know that oftentimes one needs to come back and pick out those particular numbers and maybe even to meditate on 26 millivolts and why it's a part of the world around us. Thank you. We'll see you in the next segment.